Hey everybody, welcome back to Extinction. This time we're talking about the return of extinguished behaviors. How do these pesky behaviors come back after we've already tried to extinguish them? So as we've talked about a couple of times already, extinction isn't forgetting. It's not unlearning, right? You don't forget how to perform the response you used to do. You don't forget the associations, right? A child that used to be reinforced with attention for crying isn't going to forget that used to work, even if they have learned the new competing association that crying doesn't always result in attention. So what can make these faded behaviors return with vigor once again? Well, the first thing we're talking about is spontaneous recovery. Spontaneous recovery is kind of what it sounds like, the sort of spontaneous or unprompted return of an extinguished behavior after some amount of time has passed. That delay is variable based on what we're talking about, but it's basically just defined as the return of distinguished behavior after a delay. In spontaneous recovery, the behavior may spontaneously occur in a situation in which it was reinforced in the past. So in the example of crying for attention, perhaps the child might resume crying in a place where it's worked previously, so crying in the supermarket to receive a piece of candy or something like that. That might spontaneously happen again, even after the behavior has been extinguished, even if the child has received no reinforcer and has not attempted to cry in a store for attention in several weeks. It can spontaneously occur when returning to that environment. So there's other ways that extinguished behaviors can return as well. The first one that I'll mention is renewal. This is the idea that a change in context can cause a robust return of the conditioned responding that's been extinguished. This is just kind of getting at the idea that extinction learning is often really context-bound. So if an animal learns about an association in one context, we'll call it context A, and that association is extinguished in context B, if we test the rat for its memory in context A, it's going to show robust return of that condition responding in context A. We test it in context B, however, it's going to show that suppressed responding, the faded response from the extinction learning. Right, let me give you a more concrete example. So let's say we're talking about Pavlovian fear conditioning, that a rat learns that a auditory tone predicts a foot shock. And they learn that in context A. So they learn to be afraid of the tone. Then in context B, we put them in a separate context, and we play that tone and don't deliver any shock, so no US. So the CS is presented without the US. Initially, the rat's going to show a fear response to that tone, but over time, that fear response is going to diminish as extinction learning becomes established. So if we test the rat after that in context B, it's going to show a very low amount of fear to that tone. But as soon as we take that rat and put it back into the original training context, it's going to show a fear response once again, suggesting that one, there was no erasure of that associative memory, right? We had a new memory that we learned, but we didn't erase the old one. And two, that there's a strong context effect, right? That the location where you're learning stuff is part of that learning experience, and it matters for expression of a memory, especially when you have two memories that are competing for expression. So the next thing we're going to talk about is rapid reacquisition, or savings. This is the idea that reacquisition of a conditioned response is usually faster than the initial acquisition. So let's say, for example, we have a rat in an apparatus with two chambers. And in one chamber, as soon as a tone goes off, an auditory tone, immediately after that tone, there's a shock delivered through the floor. So the rat learns, through a little bit of trial and error, that it has to leave that compartment whenever it hears the tone. Okay? Let's say that the tone stops predicting the shock, right? We stop delivering the US following the CS. That's going to extinguish the behavior. The rat's going to stop leaving that room when it hears the tone because it doesn't need to. You can imagine that if the tone once again starts predicting the shock, if we put that US back, the rat's going to learn much faster than the first time that it has to leave that chamber. This is another piece of evidence suggesting that extinction is new learning rather than unlearning, right? Across many different situations, animals will reacquire, and people are animals, but animals including people, will learn a response that has been extinguished faster than the first time they had learned it. So you're not unlearning things with extinction, you're not forgetting things necessarily with extinction. It's just two competing memories. So reinstatement is the idea that exposure to the unconditioned stimulus or the reinforcer causes recovery of a conditioned response that has been previously extinguished. So we often talk about reinstatement a lot in terms of addiction, like addiction models. The idea that somebody can be staying clean for a while and then exposure to the reinforcer, so drugs themselves, or things that are conditioned reinforcers, so things that are closely associated with the drug use, can cause a relapse or the return of that conditioned responding drug-seeking type stuff. But it can also happen in other settings. So another example, to go back to our often used example of the child crying in a store to receive a piece of candy. Let's say it's a certain type of candy, a chocolate bar. That child encountering a chocolate bar, even in a different context, or even without having had performed the behavior of tantruming or crying, that could cause reinstatement, the return of that tantruming behavior because they've been reminded of that reinforcer. Okay, let's go through a couple of examples of these phenomena. So here's the example we used earlier. Child throws a tantrum in a store. Then the parent gives some candy to quiet the child. Then later, the child throws more tantrums in the store, right? So here we have the complete picture of reinforcement. Next, if we change that middle response to no response, so we're no longer reinforcing this behavior, the tantruming behavior, eventually this tantrum throwing behavior should fade, right? And that's extinction. Okay, so how do the things that we've just talked about play into this? Okay, so immediately following extinction, this is the kind of behavior that we would expect, right? The child enters that same store, but the child does not throw a tantrum, right? The behavior has been extinguished, so there is no performing of that tantruming behavior. Okay? What if we go back a couple months later and we see spontaneous recovery? This would be if the child enters the same store and then tries throwing another tantrum to try to obtain that candy reinforcer, right? Spontaneous recovery is with nothing else happening, just the passage of time, seeing a return of the previously extinguished behavior. Renewal would be something that results from a change in context. So let's say that the child enters a different store that also has candy, but it's different from the one they learned that the tantruming does not produce candy association. So in this different store, they try throwing a tantrum to obtain candy. So renewal is a return of that extinguished behavior because of a change in context. Reinstatement is like having a reminder of that reinforcer, right? The presentation of the US alone. So let's say the child has a single piece of candy before entering the same store. Now that child might try throwing a tantrum to obtain more candy, right? Reinstatement, presentation of that reinforcer alone, causing a return of the previously extinguished behavior. And finally, we have savings or rapid reacquisition. Let's say the parent begins giving in once again, so they start giving candy in the store again to stop tantrums. The child will rapidly accelerate the tantrum throwing to a high frequency, right? They will learn very quickly that they can do this again. And it doesn't have the same learning curve as before, they will learn much faster. As I alluded to earlier, a really common use of what we know about reinstatement is using animals to model addiction and relapse via a reinstatement model. So how this works is the subjects, usually rats or mice, are trained to perform behavior to receive a drug. Usually something simple like pressing a lever. After that, behavior has been acquired. We have a period of forced abstinence. Basically, it's an extinction training session, right, where they're put into the context with a lever. Pushing the lever will produce no drug. This is meant to be analogous to people who are addicted and are then removed from the situation where they can receive drugs. This might be moving to a new place or incarceration or a treatment facility. They can attempt to seek drugs but will not be successful, so the behavior extinguishes. Following that, we have the introduction of stimuli that will provoke renewed responding, which we could call a reinstatement. This could be drug priming, which is a small dose of the drug. So let's say the rat's been trained to press a lever to receive cocaine. Giving them a small dose of cocaine would serve as a reinstatement stimulus. Stress is also common, so there are a number of ways of stressing animals. Causing a rat to become stressed out will also provoke reinstatement. Likewise, cues previously paired with drug delivery. So we've talked about secondary reinforcers, the idea that or conditioned reinforcers rather, the idea that something associated with delivery of a US will become reinforced in its own right. So for example, like a Q light, a light that goes off in the cage when a drug is delivered, that becomes associated with the drug and becomes a conditioned reinforcer in its own right. So presentation of a conditioned reinforcer, a Q previously paired with that drug, can also cause reinstatement. So here's an example of what that might look like. So in this situation, we have two levers. There's a control lever, which is a lever that never produces any drug delivery. It's just meant to sort of give an index of general non-specific behavior in the box. Here we have the drug infusion lever. So pressing this lever will result in a delivery of some drug. Here in the second phase, we have our extinction phase. So at this point where the dotted line is, the lever will no longer result in the delivery of that drug. You can see extinction takes place pretty rapidly here, and before long we're all the way down to near levels of control lever pressing, so extinguished behavior. And then presenting any of those three things we talked about previously, a cue associated with the drug, a stressor, or drug priming, a small dose of that drug will cause reinstatement. So we have a model for relapse right here. You might wonder, why do we want to model relapse in an animal? Like, why do we care if we can get a rat addicted to drugs and have a rat have a relapse? Well, there's a couple of reasons. One, we can test out interventions, right? So pharmaceutical or behavioral interventions that could then potentially, hopefully one day be translated to human populations. It also lets us learn about the neuroscience of what's happening, so we can learn what brain regions are important for learning about drugs and associations between cues and drugs, and learning what brain regions are at play when we have things like reinstatement, or neurochemical factors, things that are happening in terms of neurochemical signaling that are underlying this whole process. The whole idea is to learn more about what's happening in an addicted brain that's undergoing a relapse, so we can hopefully understand it better and come up with promising new translational treatment. That's just one example of what we can do with behavioral neuroscience, right? We lean on really, really well understood behaviors like extinction and reinstatement and use those to learn more about what's happening in the brain with complex processes. Okay, everybody, that's it for extinction. Thanks for hanging in there. That's all we're doing for this time. Next time we'll be on to punishment. And I apologize, I just can't get over how ridiculous the illustrations in the book are. They fill me with a sense of dread, and I can't get past it. Okay, see you next time for punishment.